Hello guys, welcome to Get Alert channel. Today we are going to discuss about problem solving on normalization forms. Look at this problem. A functional dependencies of the relation R ABCD attributes are given below. These are the functional dependencies. And the question is highest normal form satisfied by the relation is what? I said you already, if they are given like this, first you should believe that it is already in 1NF. Because if that is in 1NF, then only we can derive this functional dependency. That's why. And now we should check whether it is in 2NF or not. The next step is this. Step 1. Step 2. For 2NF, we need to find the candidate keys. What are the candidate keys of this relation? First I am doing AC closure. What I will get? A, C, D. With D I can get A, B, C also. I can get B. So AC is a candidate key. We can say that, but we can derive this A through D now. So DC is also a candidate key. We can't say we don't need to mention C also, because with C we can be derive it with D. So D itself is a candidate key. You look at this. If I get D closure, with D you can get C. With D I can get A. With D I can get B. You see, I got all the attributes with D. So D is a candidate key. Now let us check B. If I take B, what would be the possibility then? If I take B closure, I can get only B. I can't get something else. So B is not the candidate key here. Can I get B by something else? You look at this. AC is there. D to A is there. D to B is there. D to C is there. So these are the candidate keys. So B is not the candidate key. These two are the candidate keys. What are the primary attributes of this relation? A, C, D are the primary attributes. Okay, cut. We got primary attributes as A, C, D. Now what are non-primary attributes? Other than AC which are present, they are non-prime attributes. So B is non-prime attribute here. So is there any partial dependency? Can we expect that from here? This is a candidate key. AC is a candidate key. So we should leave that. You can say D is a primary attribute because D to B exists. This is not in 2NF. But this is not the case here. D is a primary attribute, okay. But D is itself a candidate key. If a candidate key itself derives a non-prime, this is not partial dependency. Partial dependency means it is a prime attribute, arrow non-prime, means it is any non-prime attributes derived by prime attribute, then it is partial dependency. If the prime attribute is itself a candidate key, then it is not a partial dependency, because this non-prime is completely depending on a candidate key. It is not depending partially on an attribute. If here there is something called as the proper subset, you can say that. If here is the proper subset of candidate key to non-prime attribute, if it is a proper subset of candidate key to non-prime attribute, then that is partial dependency. If it is itself a candidate key, then that is not partial dependency, that is full dependency. So this is in 2NF. Now checking for third normal form. Third normal form, what I have told you, if x derives y is a functional dependency. Either X, this should be a super key, or Y should be a key or primary attribute. Here look at this one. AC is a candidate key, means that is a super key. D, these are all super keys only. So this is in 3NF. Like this. Now I am checking for BCNF. Our first step is clear, second step is clear, third step is clear. Now we need to check for BCNF. BCNF, what is the condition? If X to Y is a functional dependency, X should be a super key. Look at here, AC is a super key, D is also super key. So this is in BCNF. This is the highest normal form, we can say that. Because in GATE exam 4NF, 5NF are not there. You can do up till this one. Remaining dependencies are not required. So highest normal form, you can say this is in BCNF. Note it down. Take a look at this question. If a relation R ABCDE with candidate key AB, they have given what is the candidate key. So candidate key is AB. So what are the primary attributes you can derive from it? What are the prime attributes? A comma B are prime attributes. What are non-prime attributes then? Those are C, D, E. If you look at the functional dependent, what they have said is in 3NF. So this is already in 3NF. That means it is in 1NF, it is in 2NF also. Then which of the functional dependencies are invalid if it should be in 3NF? First I am looking at option A. ABC, this functional dependency is given. What is the mean by 3NF functional dependency? If X, Y, this is the functional dependency, either X should be a super key or Y should be a primary attribute or candidate key. Y should be a primary attribute or candidate key. You can say simply a key. That's all. And now AB is a candidate key. That means it is already a super key. So this is valid only. DE, if you look at this, DE is not a super key, but B is primary attribute. If you look at this, B is a primary, so this is valid. If you look at AB to D, AB is a super key. So our condition is applied here. Both are, anyone is satisfied, that means it's in 3NF. So this is valid. Look at here, CD is not a super key, or if you look at this, E is not a primary key or a candidate key. So simply we can say that this is invalid. Like this you should solve this question. Note it down. Now try to understand this question a bit. Take a look at this question. Functional dependencies are given for relation. The relation R is in which normal form? This is the question. Try this question. This is a very good question, and the answer will be provided in the link in description given below. Thank you for watching this lecture.